Okay, go on. I just
Okay.
start recording. Go on.
Okay. So any student can open this file.
Yes.
For example, put them. Okay, thank you. So this is the frame. This is the line. Okay. So you have to extrude this line, and the distance on this extrude is 3.24 meters. So you can extrude these lines 3.24 meters. So you see, so the surface, okay? But in this case, we can improve the surface in this form. So use the command dot border, or in Spanish duplicar border, dot border, and then delete the surface. So with this border, click on explode, and then create a new surface, but using this command, surface from network of curve. So you see, okay. So you see a new surface that is better than the previous one. Okay, then you have to use the command contour, in Spanish contorno, contours, and then specify the base point, the directions, and the distance between contours is 1.08 meters. And you see, okay, the side plus bottom, but with these two lines in the middle. Okay, in order to do the web of the frame, so you can use this command. The command is called extrude, but in this case, normal to the surface. So click, for example, to this line, and then go to the surface, extrude curve, and then normal to the surface. So then the programs tell that you can select the base surface, select this base surface, and then the distance of the extrude. And this case is the web of the frame, and the web of the frame is 200 millimeters. So in meter is 0.2. Okay, so minus 0.2 meters, 0.2 meters, and then enter, and then enter. So you see, okay, the web of the frame. Okay.
Is everybody with you? People, is there any
Student.
questions about this so far?
I just have a question.
Yeah.
I mean, as we know, there are some commands that we can use to create that surface.
Okay.
But I just want to know, is the command that you are showing us is the only one that we have to use, or we can use another, like sweep?
There are some methods in order to create a, but for example, what happened if you, for example, draw the profile of the frame? For example, in this case, is 0.2 meters. Okay, and then the profile of this tip of the flange is 0.06 meters. Okay, and then move. So you can, for example, use in this use the command extrude along the curve. For example, you can select the profile and then surface. Okay, sorry, surface extrude and along the curve, and you select a path. You can see, okay, you can see the surface or the element,
All
and
right.
this is wrong.
Okay.
Okay, so for this exercise, is better use this method, normal to the surface. Okay.
Okay. Thank you, engineer.
Okay, and then so you see, for example, in the other view, that this extrude, for example, is not vertical. Okay, the same for the deck. So the line is the end is not vertical, it's inclined because it's normal to the surface. Okay, so in order to improve that, you can trim the surface in this way. So you can, for example, extrude this line. So this extrude this other line. In the other directions. Okay, select directions. So there, so you see that this is not straight, this end and the other end, so you can trim the surface. So select this surface and the frame and this other frame, and then put the command trim and trim this little piece and the other little piece. Okay, so now is better web. So then you can delete this extrude and you see now the web. So questions so far, some students came behind the explanations. For example, Vera, just Vera.
Yes, engineer. I'm following you.
Okay, and Peralta, Peralta,
Yes, engineer.
Peralta.
Yes.
Okay, okay. So now we're going to complete the frames and draw the flange. So you have to draw the flange, and the dimension of the flange is 60 millimeters, so 0.06, because the unit of this geometry is in meters. Okay, and then enter, and then move. So you can, so for this flange, in this case, it's better to use surface through the curve and then along the curve. So the path is the line of the web, this line. So you see, okay, the flange. Okay, so you can select the flange plus web and then copy and put in the other line. Okay, so the final step in order to complete this model is to select all the lines and then delete all the lines, because we can export only surface. So you see the plate and these two frames. So then the next step is to save using EHS format, right? In order to import it to ANSYS. So files, save as, and EHS formats. Using EHS formats. This can I call side plus side bottom right. And the format is EHS and save. Okay. So everyone now open the ANSYS workbench. Okay, open the ANSYS workbench. Open the ANSYS workbench. When I finish this explanation, I ask some student to show me some results. Okay, so try to do it, this exercise in this class. Okay, this is the file that we used in the previous classes. So so we are going to drag another static structural to the white space, and then to click on geometry and select new design modeling. So these two the step you know, because the previous class. So it's not difficult for you. So file and then import external geometry and select the ES file. So the ES files, side bottom plate, this is the geometry, and then generate. So you see now there, you see the geometry. Now you can see this white surface, and then you can rename So for example, in this case, this is the web. I call web ones. This other is the other web 2, and this other is flange 1, right? So this is flange 1, and this is the other flange 2, and then this is the blade. Okay, so in the case of the plate, what is the thickness of this plate? Some student, can you tell me how to assign how to assign the thickness?
6
For
millimeter.
example, okay, but how to assign?
We have to click on thickness mode and
Okay.
define it by user, and we in thickness we have to change the value.
Okay, so plates, so think more use define, and then the value is 0.08 because the unit is a meter. Okay, so the others, the thickness is 6 millimeter, the width and the flange also. So you can select in the same time, and then set up the thickness mode using define it, and then the value of the thickness. So 6 millimeters. So you see that this every element have the thickness. Well 1, well 2, flange 1, and flange 2. Okay. So this is the step in order to compute the geometry. So go close this window, and then always save the program, save the project.
Always.
Okay, and then go to the models. So this is new for you. In this model, we are going to specify the mesh, boundary condition, load, and parameter of the solution. Okay. There. Okay, you see, so the geometry, okay, is correct. And then in the mesh, we are going to use two different mesh, one for the plate and the other for the web and flange. Okay, so right click on the mesh, every student, right click on the mesh, and then insert, but in this case, insert sizing. Okay, sizing. Insert two sizing. Again, mesh, insert a sizing. For the first sizings, select the plate. So use these face controls and then select the face. Okay, for these elements, you can go to the geometry and apply it. And then in the element side, the value of the element side is 60 millimeters. Okay. And the other sizing is for the frame. So you can select the frames. Okay. You can select this web, and if you keep hold the control key, you can select every several surface. So keep hold the control key at the same time, and you select, so you select this key for surface, and then specify the element size. For the element size is 20 millimeters. Okay, so you can click on mesh and then generate mesh. Okay, so you see the mesh of the plate and the mesh of the frame. Okay,
Engineer,
so there are okay, bye.
good morning. Uh, how select the flange and web for sizing 2?
Okay, so you have to keep hold the the control, using control in order to select several or more than one surface. So
Okay,
in the face sizing, okay, so for example, select this and hold the control key, and the other one, and the other one in this form. So you see that the surface, when you select a surface, the surface, the color of this surface is green.
thank you, Engineer.
Okay.
In the face sizing one is 50 millimeters.
Yeah.
Okay, thank you.
Okay. So this is the mesh, but there is not connection between, for example, the frame and the web of the frame between the plate. Okay, there is no connection. Now we're going to do this connection because the structure work together. Okay, so
Isaac, would you do a zoom so they can see that the joints of the bottom plate are not connected to the exactly there? That's the same problem that some of you had in the previous project, that there was some joints where we're forming one element, but we're not connecting to adjacent elements. In this case, the vertical elements are not connected to the bottom elements. Go on, Isaac.
okay, in order to do that, you have to click on mesh and then insert mesh connection group. Go to insert a mesh connection group. So you see a mesh connection group, and then first right click on the mesh connection group, and then click on the first detect connection. Detect connections. Immediately you see 3 connections. The program missing, for example, this connection is the connection between the flange and the web. Okay, these other connections is between the plate with the with the web of the frame, and the other connection is the other flange with the the web of the frame. Okay, so in the mesh connection group, you have to first detect connection and then generate.
Engineer, sorry, you can repeat how generate the 3 connection group?
Okay. Right click in the mesh, insert, and then go to the mesh connection group.
Yep.
Okay. When you have mesh connection group, click on mesh connection group and then first detect connections and then generate. So first detect connection and then generate. So now, for example, you see the connections. You see the connections of these between plate and the web. So you see, for example, in this part, okay, the connection between the plate and the web. So maybe some students have one question in this figure. You can see, you see some strains.
In
What
the
happened?
in the other
Okay,
web, we don't have connections.
okay, that is the answer. So this is a propósito. So in order
on
to
purpose.
a purpose, okay, because you can do a disconnection by using manual connection. Okay, so now we are going to use that. Okay, so if any connection is not appears, you can do it by manual connection. Okay, so click on mesh connection group, insert, but in this case, insert manual mesh connections. Manual mesh connection. So in the primary geometry, you can select the big element. In this case, the plate. So select the plate and then apply. And the second geometry, you can select only the lines. For example, the profile of the web. In this case, you can select this line and select this line. Okay. So you see this line and then apply. So the connection is created now. Okay, and then finally generate. So you can see the mesh, and now you see the connection between the two elements, the frames and the plate.
Zoom, zoom, zoom. This is something that we should always do. okay? Open your connections, make a zoom, and check yourself. The elements are indeed well connected.
Okay. So
Isaac,
okay.
this explanation about the manual connection is not in the notes, right?
No.
No, so okay, that's something that we have to improve for next year.
Okay. Okay. So, okay, you see the connections. Okay, now, now, we are going to apply boundary conditions. So insert fixed supports. For the fixed supports, we assume that all the edges, all the border is clamped. So for that, you can select all the line, all the edges, include the line of the profile of the frame. For example, select using Control K these lines, this line on this profile on the frames, and the others. So you can select the lines or the edges. Okay, the other ones, and then okay, select this part, and then select this line, these other lines, and finally now. So then apply. So there are two edges that you have to select. So every edge is clamped now. Okay, and then you have to insert hydrostatic pressure. Hydrostatic pressure. So maybe so far there are some questions. Is there a question so far, student? Let me
Please repeat the file support is what is the selection is.
okay. Okay. So let me delete fixed support, right? So insert fixed supports, and then you have to select all the edges. So we can assume that in this edge there is a ball head, there is a ball head in the other edge. In the middle there is a longitudinal edges, the longitudinal ball head, and then there is a strain deck. Okay, so in this exercise we assume that the border is clamped. Okay, so in order to do that, you can select all the edges using this icon, using lines, and then Control K. Okay, using control in order to select several lines. The other lines. So the profile, the profile of the frame in the edges. Okay, this line and this other line. The same for the others. Wacom. Wacom.
Yes.
Okay, so go to the this other line and this other line. So all the edges, the border, and then this other, and then this, that, and finally this and that. So every edge is selected now. So apply. So there are two edges that I select in order to put the picture support. Okay, so the hydrostatic pressure. So you can insert hydrostatic pressure and then select the geometry. So you can select the surface and apply. Okay, the fluid density, you can change the unit in units. Okay, in order to this, the unit is kilogram per meter cube. So the fluid density is 1,000. Okay, and the hydrostatic accelerations, you have to define node by vector instead of vector components. The accelerations is in C components, right? And the value of the acceleration is 9.8. Okay, you see more or less. And then finally, you can select, okay? So the free surface locations. In the X coordinate, put 0 value, 0. In the Y component, 0 again. And the C directions is the draft. So the draft, you can select the draft for this exercise, and the draft is you can input this value 3 meters. So you can see, okay. So I repeat again.
Isaac,
Okay.
what we can do is those students who has a last name with letters A through M use a draft of 3.5, and the rest from O to Z use a draft of 2.5. And let's see if we can compare with yours. Okay.
Okay.
Just to try something different, not to follow recipe. And I think it's time to make a break, Isaac.
Okay, yeah.
Okay, let's make a break here. And if you are a little bit behind, try to catch up during these 5 minutes, okay? And then, well, what we can do is we can complete this exercise, try to see if there is any doubts. And then what we can do is next session, we will do a progress control. Okay, there's no problem with that. So right now, what we need you is you feel comfortable using these tools in order to start your analysis. Okay, so let's make a break.